Okay, so let's start our session. If it's a sinusoidal frequency estimation, we consider the signal model xn equal to cosine 2 pi f0n, in which the frequency f0 is to be estimated. The LSE is found by minimizing this. This is what? Just using the x minus the s. Okay, this is the s. You're using this minus s, but s is this. So in some sense, this problem becomes very simple. If we recall how we estimate the frequency component in the maximum likelihood sense, it was actually very complicated. It was actually very complicated. So in this case, going from here to here, it's very simple and easy. Okay, but in contrast to the DC level signal for which the minimum is easily found here, the LS error is highly nonlinear in F0 because it has this cosine term, so it's highly nonlinear. The minimization cannot be done in closed form. Since the error criteria is a quadratic function of a signal that is linear in the unknown parameter, use the quadratic form for J, right? Quadratic form 二次式，它这个是一个二次项。As in the previous example, the minimization is then easily carried out. A signal model that is linear in the unknown parameter is said to generate this linear least square problem. Otherwise, in this problem, the problem is nonlinear least square problem. Okay, and one point to mention is nonlinear LS problem are solved via grid search or iterative minimization. Like Newton method or grid search. What is a grid search? You cut F0 into many grids. For example, from maybe 100 hertz to 1,000 hertz. You cut it into 1,000 or 10,000 or 100,000 subsections, and then you search for the F0 that minimizes this J， 也就是把它切成很小的段，比如说100赫兹、101赫兹、102赫兹，或者你要切更小，你也可以把它切成100.05、101、101.05这样子，一直切成很细的小格子，然后就去一个一个算，每一个 F0 都算出它的阶值，然后去找出最小的阶值，这叫 grid search。这就是数值方法那一门课或者课本其实常常用到的问题，用到的技巧啊 ，grid search 的方法。Or like iterative approach, like Newton method, Newton-Raphson method. Okay. Then the next example, sinusoid amplitude estimation. If the signal is S0, sinusoid amplitude estimation. Okay. If the signal is Sn equal to A cosine 2 pi f0n, where f0 is known and A is to be estimated, then the LSE minimizes this, right? But we have to know what is known and what is unknown. This is known. This is unknown. This is unknown. So this is easy accomplished by differentiating J of A in quadratic in A. This is a linear LS problem. Well, have we talked about trigonometric function as a nonlinear function? Then how come we are saying this is a linear function? Because since f0 is known, cosine is a constant, right? 就是 f0 是 known 的，所以这个是一个 constant。那 unknown 在哪里 ？unknown 就只有 a， 所以还是这个是一个 linear。 If, however, A were known and frequency were to be estimated, then the problem would be equivalent to that as a nonlinear function. Okay. A final possibility in the vector parameter case is that both A and F0 might need to be estimated. Then the error criteria is like this. And you notice that this A is in the unknown and F0 is in the unknown. So it's quadratic in A but not quadratic in F0. The net result is that J can be minimized in closed form with respect to A for given F0, reducing the minimization of J to over F only. Okay, but if you want to search for optimal solution, you actually have to jointly search for F0 and A. But you know, in this case, you could solve for A first, and then using that A to solve for F0. Okay.